You hear all the time that Spark is much better than regular Python's modules like Pandas for batch processing, for big data, and these kind of situations. So in this video, I want to show you a really simple example to prove that actually Spark is doing better than Pandas even in a single computer, because tools like Spark shines better in situations where you have clusters of nodes, clusters of computers and servers, so you want to distribute your processing. But even with single computer, I'm gonna show you that even in that case Spark works better, and the reason is that by default it tries to distribute the processing throughout the processing power the computer has. So it uses all the capacity and all the cores of the CPU to do the processing in parallel. While when it comes to Pandas and processing big data, it tries to do everything in order by default, and it doesn't use the whole capacity of the CPU. Now when you start working with Spark, it's not really easy to find an example to prove this point, because in reality we usually use Spark for big data and also on multiple nodes. So in this video, I want to show you first of all how you can create and generate your own big data, and show you a quick example that Spark actually works better. Okay, let's get started. Here is the article I have. You can find all the codes and everything that I'm going to share with you in this video. You can find it here. The result and the code is going to be here. You can just copy and paste it. So the very first thing is having a big data. I realized that it's not that easy to find big data, but for testing purposes, you don't actually need actual data. You don't need real data. What you need instead is just creating a fake data. So here is the code I have here, and I need to admit that I just created this code with ChatGPT. It looks quite good actually. So here it tries to just fake some data to have like 20 millions of rows here in this example, to have 1 gigabyte of data for each file. So we can generate, for instance, 10 files or 20 files to have 10 or 20 gigabytes or even more data for our testing. It doesn't really matter what this data is about, and it doesn't even matter if the data is unique or it's duplicated. Generating this data takes time. So I highly suggest that to just create 5 or 6 files and then try to copy and paste it over and over to have like 10 or 20 gigabytes of data. Because for the sake of this example, we just want to test the speed. We don't actually want to work with the data itself. You can just create a simple file and then copy and paste the code there. Already have this file here. So this is the file I have, make data.py, and the same code you saw in the article. Let me change it a little bit so that I can less files here, so I don't have to wait. Something's wrong here. It should be like, I'm gonna change it for like 2 files to just prove to you that it works. Make data.py. It's 20 millions of rows, so yeah, it takes time. As you can see, this is the CSV file we have. So I can just stop the code here because we don't need it. And I just need to go to data folder. It's better to put it in data folder in the root of the project. So here you can see that I have all this data, and basically I copy and pasted half of them based on the first half, and it doesn't matter if the files are separated. Now it's time to actually test our example. So here I have this code in Pandas. Basically what it does, it reads all the data from that folder and then try to add a new column, it's revenue, which is actually the quantity multiplied by price. And then we're gonna have revenue for that row. And then what it does, it uses group by to actually have the whole revenue for that product line and also the customer name. And then it's gonna sort it by revenue. So we're gonna have the top product lines along with customer name based on revenue. and eventually it prints out the time of execution. Again, I have this code already here. You just need to copy and paste it. Nano process with Pandas. And as you can see, this is the same code. And let's just simply run it with Python. Process with Pandas. As I've written already in the article, it's going to take like 123 seconds, or basically 2 minutes. After that, we're going to try the same example with Spark. So when it comes with Spark, we pretty much want to do the same thing. So here we read the files, and then we add a new column of revenue by multiplying quantity by price, and then we group the data together to have revenue for each product line and customer name, and then we order it, and then eventually we're gonna have the execution time. But the difference here is that it's gonna run on Spark, or with Spark actually. So here we have this Spark session, and as you can see, we have a really small configuration here, shuffle partitions. Basically it tells that I want to have 8 partitions, so it's gonna split the data in different partitions and then run the whole process in parallel. So that way it doesn't have to read the files one by one. It can load the whole data in parallel. So it uses the whole capacity of your RAM and your CPU and do the process parallel. One more thing about Spark is that we have something called catalyst. And basically it means that Spark behind the scenes, before the execution, before actually doing this show execution, it does some optimization on the query to have the best and fastest query. Okay, now as you can see, it took like 118 seconds, pretty much 2 minutes. Now let's try the same thing with Spark. I have the same code here, Python process with Spark. It's the same code as you see here. You can just copy and paste it. Let's run this. As you can see, it only took like 40 seconds. It's much faster than using Pandas simply. What's different here? As I'm talking to you, maybe you can hear it. There is this sound of the fan that is working so high, and it's mainly because the CPU usage went high. It's using the CPU a lot more for this task when you run it with Spark. But usually when you have this capacity, you prefer to use it instead of just not using it. There is another way to run this kind of codes with Spark, and it's Spark submit actually, instead of running it with Python. In most cases, it doesn't matter, but it's much better that we run it with Spark submit. But sometimes Spark doesn't work with simple Python, so you just need to use Spark submit, and then the code you have. And I guess that's it for this video. I just wanted to show you this quick example to see in reality that Spark actually works better even with single computer, with single CPU, but if you have multiple cores, it's gonna work much better. I haven't tried this with single CPU, with single core. I'm not sure, but my guess is that it's gonna work a little bit better, and the reason is that because it has all the optimizations behind the query, and as well as it uses a combination of reading from RAM and having the data in disk all together. But there are a lot of features and optimizations happening with Spark, so it's really hard to say that why it's working better, but it's mainly because of all these things together. I hope you enjoyed this video. See you soon with another data engineering video. So take care.